Okay, so good morning. I think this is lecture 9. I hope in the last 8 lectures, you might be enjoying the beauty. By the way, I think some of you might be finding it difficult to absorb, right? And the reason is not that you are not talented or you are not very, not having good mind. The reason is the habit of how do you study, okay? Because I think up to class 12th or in some coaching, they give you solutions and so on, and you just memorize and try to memorize as much as possible. But I think if you just break that thing, it will be very easy for you to absorb the material, right? So each of you are very talented, young people, right? So because I think at your age, people have done a lot of great work by the age of 17, 18, right? So you are also having the same mind. It's slightly different, but by the way, some people will say that I hate this subject, I hate the other subject, right? That happens. So, एक बात बताओ. So, when you listen to some music, sometime immediately you like it, right? But sometime if you repeatedly listen it, you start liking it, right? And that is the beauty of brain. So, if you give enough exposure of something, you will start liking it. So, what you require to enjoy the beauty of mathematics? Bunch of cup of coffees or maybe tea. Or if you don't like tea and coffee, maybe a juice, fruit juice, right? And then just give enough exposure and you will start liking it, okay? Now, all these epsilon delta and epsilon L methods, you remember, the trick is about solving inequalities. Rest is very straightforward. Definition is not going to change, right? That will remain the same. Using the tricks of inequalities, epsilon is assumed and delta is fine. Delta you find in terms of epsilon, right? You find that thing using the inequalities. That is the only trick for all the problems, okay? For epsilon delta. Similarly, in case of epsilon n method, given epsilon is given, you can find capital N in terms of epsilon, right? That's the only thing. I mean, nothing, there is no rocket science here. Such a simple thing, right? Now, if you are having difficulty in basically solving inequalities, that might be an issue, right? So there is a very nice book, Inequalities, by G.H. Hardy. So you can look at that book, which talks about different kind of inequalities. I enjoyed that book at the age of 17. It's a beautiful book by Hardy, right? So you can actually look at it, right? So all these things are available these days, right? So I hope you will not have trouble, right? And again, I'm asking you, just make a habit of 3-4 students in a group, and I'm just again reinforcing whatever I have said. I have already said these things, but बार-बार injection देना पड़ता है ना, repeatedly interval, so that you are in the same page. Otherwise, what will happen? You will lose. You say that I don't know what is happening in the class. It is very difficult, this and that, right? It is not difficult. It's your habit of reading is different, okay? And because this is a university system, and that's why I said in the university system, people are not going to give you every solution, right? You have to discover, because the joy of finding the solution by yourself is another beautiful thing, right? You will enjoy it, okay? So that's the thing. So I think towards before the exam, probably I will summarize whatever we have done for the entire thing, right? So what are the important tricks to handle? Anyway, so today I'm going to start this differentiable functions and some of its properties. And I think before that, I think so last class we were looking at continuity. So continuous, when a function is said to be continuous, the function f of x is continuous at a point x is equal to a, which is a real number. If for every epsilon positive, there exists delta positive such that mod of f of x minus f of a is less than epsilon whenever mod of x minus a is less than delta. Right? ये तो बिल्कुल ब्रह्म वाक्य की तरह याद हो जाना चाहिए, right? So now, and I also talked about uniform continuity. So normally delta depends on epsilon as well as the point A under consideration. When it is independent of the point A under consideration, the function is said to be uniformly continuous. And normally, by changing the domain, you can make a function to be, uniformly continuous or only continuous and all kind of things. So there is an alternative way of showing something uniformly continuous. Of course, that if you try to find delta in terms of epsilon only, I mean, there is no a, then obviously function is uniformly continuous. But there is an alternative way, which I'm going to give you just one example to show you how to show that, right? And that is also a trick which is quite often used for showing that a function is uniformly continuous on some domain. Okay. So what we do, we take two arbitrary points x and y in the domain. Okay. And just compute mod of f of x minus f of y. If mod of f of x minus f of y is less than epsilon, whenever mod of x minus y is less than delta, you are done. We are saying that you take two arbitrary points in the domain, and these are very close point, x and y. And if it happens that the corresponding images are also very close, right? So then the function is uniformly continuous in the domain, right? So let me show you one example. Okay. So if you take function to be, say, sin x, you know that sin x is a beautiful function. I don't know whether you know this fact, but this also appears in love affairs, sine and cosine actually. When you model love affairs, actually these two functions appear. It's a simple harmonic motion between two people anyway. So so sin x is uniformly continuous, right? I want to show this. What I'm going to show now, I want to show that for every epsilon positive, there exists delta positive, such that, so normally I should show this, show that if x is a point, so basically our domain is whole real line, right? I mean, so domain is real line. So what I'm going to show that, suppose I take delta to be epsilon here, and I take this difference. So x and y are two distinct points on the real line, right? And you consider mod of sin x minus sin y. Now, I think if you are clever enough with the inequalities, you can show that the whole thing is less than or equal to mod of x minus y. You can also use mean value theorem. I think you might have heard, right? I mean, whatever way you arrive at this. So this whole thing is right. Now, we know that what I said, I should show, in fact, I needed to show that mod of sine of x sine of y should be less than epsilon whenever mod of x minus y is less than delta, right? So I'm saying that if this is less delta and this is equal to epsilon, we are done. So this is what you need to show. A function is uniformly continuous if you take 2 points x and y on the real line, and then difference of image is close, whenever x and y are close points, right? If this happens, then also function is uniformly continuous because it's independent of point. These 2 points are arbitrary in the domain, right? So if you are able to show that the function is uniformly continuous, in that case, here now you see that when we take delta is equal to epsilon, because of this inequality, since mod of x minus y is less than delta and delta is epsilon, the whole thing is less than epsilon. You are done. You found delta in terms of epsilon, right? Okay. So similarly, you can try to show the function 1 by x. On what domain it will be uniformly continuous? Right. 1 by x, right? All polynomials are uniformly continuous, right? So you can show all those kind of things. Now, when the function is a bit messy, the inequality will become a bit, complicated. So finding delta in terms of epsilon sometime is tricky business, but that's okay. I mean, it's all about solving the inequalities. The problem is not in the definition, the problem is solving the inequalities, okay? So maybe you should do a couple of more examples, okay, for this kind of thing. So understood this idea? Yes. No, I'm saying that you take delta is equal to, I'm providing you a solution. Take delta is equal to epsilon and we are done with this thing. Because mod of sin x minus sin y is less than or equal to mod of x minus y, right? So now I know that mod of x minus y is less than delta. So if I take delta is equal to epsilon, mod of sin x minus sin y will be less than epsilon. No, so you can choose. What is happening? So what is happening? So what is happening? The thing is that what we need to do all the time in these problems, as I mentioned, definition you can write down in terms of epsilon and delta, and now your job is to find delta in terms of epsilon, right? Which should work. The whole inequality should be satisfied. I'm doing that just that. I'm saying that now you take this delta is equal to epsilon, and you are done. Okay. So all the time you have to only solve for delta in terms of epsilon. Right? Yeah. So ये inequality का trick है. ये तुम्हारा जेई का problem है ना? So mod of sin x minus sin y is less than or equal to mod of x minus y. ये जेई का problem है, right? How do you solve? How will you show that? अगर नहीं है तो एक चाय का कप लेके बैठो and show that. That's a beautiful thing, right? That is a right inequality. Inequality थोड़ी सिखाना है मेरे को, ये तो कैलकुलस की क्लास है, right? Inequality you know from your high school, right? Yes. No, it's not about value. You see, because the definition says that for every epsilon positive, there exists delta positive. So the definition should be universally true. When we are showing something does not exist or the function is not continuous or something like that, then you can take specific values to arrive at a contradiction. Okay. Otherwise, you need to show that the whole thing is valid, right? Got it? They are the two different things. थोड़ा practice और करो. Okay. So I know ये सब शुरुआत में थोड़ा सा heavy पड़ता है, but it's not heavy actually. It's a habit नहीं है बस ना. और मैंने वो पहले दिन की स्लाइड में दिखाया है हैबिट कैसे आती है, सोचने से आती है ना. ओके, सो दैट्स ऑल अबाउट यूनिफॉर्म. सो आई थिंक probably you can do many examples of using uniformly continuous. I mean, for uniformly continuous using these two, take two arbitrary points x comma y and show that the whole mod of f of x minus f of y is less than epsilon whenever mod of x minus y is less than delta, and you are done, right? Where delta if you are able to find in terms of epsilon, right? So then okay, now I think a very important concept. What is that? Differentiability of a function, right? A function is differentiable at a point. अब तो आसान है. So a function f of x is differentiable at a point x equal to c on the real line if limit x tends to c, f of x minus f of c divided by x minus c exists, and the value of the function is we call it f dash of c, right? ये तो पढ़ते आ रहे हो हमेशा से differentiability की definition है. And now since it is in terms of limit it is written, you can always write in terms of epsilon delta. So I leave it as an exercise for you to write down the definition in terms of epsilon delta, right? By the way, I should say that in all these definitions, I am using the distance function as distance between 2 points x comma y on the real line as mod of x minus y. Right? That is the distance between 2 points on the real line, right? In one of the sample exam paper, I have changed the distance. I have asked you to write down epsilon delta definitions there. If you look at it, and try to do that, right? So if you change the distance, the definition will be different. But all are equivalent anyway. Okay. So limit definition will be different, continuity will be different, and so on and so forth, right? Okay. Fine. So let me write down the first definition, then we'll go ahead a bit further. So we say that f is differentiable at x is equal to c if limit x tends to c f of x minus f of c. This is always a problem with me. If this limit exists, right? Then we say that the function is differentiable and we call this limit as value of f at. So I think you remember, you draw a curve, you take 2 points, all those things, the geometrical meaning of differentiation means tangent at that point, right? Rate at which things are changing of a function. It's a very, very fundamental thing. I think you know, but so I'm not repeating it. So I'm going to ask you some very interesting questions. Let me first show you. So f dash of c can be defined as, so limit x tends to c, f of x minus f of c divided by x minus c. Also, this is same thing as limit h tends to 0, f of c plus h minus f of c divided by h. Right? And I think, by the way, I have posted some of the MATLAB. MATLAB is symbolic computer. How many of you know MATLAB? Very good. So MATLAB is a symbolic computing package, right? So for calculus, they have a whole bunch of functions or scripts. I have posted some of them in the lecture folder. Actually, I will try to put it there also. You can download it and use it because we have MATLAB license, so you can just see, right? Different variations, all these pictorial representations. If you use all the things, probably the time will be very less. So I'm leaving something for you. Just click it, right? And maybe on the tutorial, I will try to ask the TAs to show you some of those things, right? Anyway, so this is a very simple thing, right? If x is c plus h, I mean you can get this, right? From there, these two definitions are equivalent, right? This is the function is differentiable at a point. So I think if y is equal to f of x, you know that dy by dx is equal to, right? What is d2y by dx2? Double differentiation. What about and so on, right? Correct? And also, I think you might have read one result. If a function is differentiable at a point, it is continuous. Very well-known fact. So I'm not going to repeat it. The proof is also very simple. Written in the notes. If the function is continuous, can you find a differentiable function? Need not be, right? So immediately comes in your mind bunch of t time problems, right? Give an example of a function which is differentiable exactly at 1 point. Give an example of a function which is differentiable exactly at 2 point, 3 point, n point. Give an example of a function which is not differentiable exactly at 1 point and elsewhere else it is differentiable. Give an example of a function which is not differentiable exactly at 2 points and everywhere differentiable, and so on. Give an example of a function which is not differentiable at all integers on the real line, not differentiable or differentiable. These kind of questions can be asked, right? So one can make pretty interesting thing, right? So you have enough coffee or whatever juice to drink over this week, right? So 3-4 days. Now another very interesting thing I'm going to ask you, something which will blow your mind. Okay, so look at it. Suppose we take function y is equal to x. What is the value? सबको मालूम है, right? Very good. What is the value? Very good. Now my question is, and this is again a t time problem. I want to differentiate half time. Half time. Now, that means I take x, I use this half time twice, I should get dy by dx. You know what I mean? I need to find out a definition. I'm asking you to find a definition of a differentiation of a function where differentiation is not done integer number of times, because you are familiar with dy by dx, d2y by dx2, d3y by dx3, and so on, but rather differentiate it half times, 3.5 times differentiation, or differentiate a function alpha times where alpha is a real number, or differentiate a function alpha times where alpha is a complex number. All these things are possible. It's all fun. You take some potato chips and coffee and you enjoy, right? These are huh? So you you. So I'm saying that you should take fruit juice if you don't, you know, but don't take preservatives. Fresh juice, Watermelon is available, I think, right, today, these days. Anyway, so basically, that's all. There are a lot of mathematicians who, they say that if you want to enjoy the beauty of mathematics, you should have comfortable chair, big, very beautiful garden, either cup of coffee or whatever juice. There is a mathematician, Erdos. He said that mathematicians are machines to translating for translating coffees into theorems. So you can also do the same thing. You need to just see the beauty. एक बार beauty पसंद आ गई ना, you will really enjoy lifelong, right? So you understood my point? I want to differentiate half times. Now this definition should be such that if I differentiate half times twice, I should get dy by dx value. Getting me? So you need to sort of generalize the definition of differentiation itself. ये शायद तुमने देखा नहीं होगा. एक punch है basically ना, to blow your mind that you can differentiate half times, right? Okay. So obviously internet पे search करोगे थोड़ा बहुत कुछ मिलेगा. I don't know whether you will find. I mean, of course, the branch is quite old. It is known as fractional calculus. Okay, fractional calculus. So there are different derivatives. Definitions are given by other people. If you want to differentiate alpha times where alpha is a real number or complex number. Okay, and many interesting things are there also. Believe me, many things are unknown yet. Okay, so many interesting, beautiful things are there. Okay, so I'm just asking you a simple example. Maybe you are able to give a new definition of differentiation, and you can even publish a paper also, right? Okay, can you define a new definition of differentiation anyway? Okay, so I think what else? Yeah, so I think here we talked about earlier. Give an example of a function which is continuous everywhere on the real line but nowhere differentiable. Remember the function? V-stars function. I think probably second lecture or third lecture I talked about that sort of, self-similar function. So normally this function is how they thought about it. So I think if you look at this picture of this function, just like looks like a stock market function, if you plot. Okay. And in fact, people are using these kind of things. This is a very mysterious function, by the way. So this function is continuous everywhere on the real line, nowhere differentiable. You cannot draw a tangent anywhere on the real line on this function. This is used in something known as accelerated computing. You can you different kind of things people are talking about. As I mentioned about Turing barrier, right? So similarly, can you go beyond that and all kind of things? So different ideas are there by philosophers and so on. So that's all. So I mean, this is something. So anybody, I mean, are you able to show that this function is not differentiable anywhere on the real line? No. Google पे proof भी नहीं मिला. Maybe you should take help of ChatGPT. So convince. See, only one thing is going to help you with that is epsilon delta, right? And if you use that, probably for that you need to develop really a way of showing this. Anyway, so I think this is something interesting. Now there are certain observations. Number one, if f dash of c is positive, so the curve y is equal to f of x is ascending, sorry. And if f dash of c is negative, curve y is equal to f of x is descending, right? So curve will be ascending if the derivative is positive. This I think you know from your high school mathematics and from your JEE exam. Third, if f dash of c is equal to 0, the curve has a horizontal tangent, right? So let's see. So I think this is pretty straightforward observation. If the derivative is positive, the function is ascending, right? Negative, descending is equal to 0. So you have a tangent parallel to x-axis, right? Clear? Okay. Now there are three very popular theorems known as Rolle's theorem. ये पढ़ा है ना? सुना है? Anyway, Rolle's theorem. Okay, so let me show you some results. So, by the way, just like that, we define derivative with respect one-time differentiation. We can define two-time differentiation, n-time differentiation. So I don't have to write in terms of limit, right? You can write down all those definitions, right? So let me talk about pre-Rolle's theorem. So it says that f is a continuous real valued function, means the values are real on the closed and bounded interval a comma b. So it says that if the maximum value for f is attained at c, where c lies between a and b, right? Some point between a and b. I mean, this is a big problem for me writing. And if derivative exists at c, then f dash of c is equal to, this is the pre-Rolle's theorem. I think we can use this fact to show the Rolle's theorem, which is the actual thing. So it's a very simple. I'll just again look at this theorem. Says that f is a continuous function. There is no break when you draw the line, or when you draw the function on a closed interval a comma b, right? So including the endpoints a comma b on the real line, right? Closed interval. If the maximum value for f is attained, now suppose c is a point between a and b at which the function has a maximum value. Okay. And if the function is differentiable at that point, it says that f dash of c is 0. Means you can draw a tangent parallel to x-axis, right? At that point. Okay. So this is a very simple result. How will you prove that? Any idea? I mean, I think we should need to develop. How do we prove it? You should think about it first. Intuitive is fine. Intuition is very good sometime, you know. By the way, do you know there is a branch of mathematics known as intuition, where you can, how do you develop intuition? Anyway, so how do we start proving? See, two popular methods in proving something. One is, because this is an art, how do we prove? And you know, as you know, Ramanujan, he used to give formulas, right, without proof. And still today, if you look at some of the last notebook of Ramanujan, which is available, I have it here. Okay, so see, there are two popular tricks. One is contradiction, which we have used many times, and another interesting thing is induction. Right. So induction is another popular technique, right? Induction where? On numbers or something, or some object, some mathematical object. So basically, here we are going to prove it by contradiction. Suppose this is not equal to 0. Then what will happen? F dash of c will be f of x minus f of c divided by x minus c. Right? So if it is not equal to 0, either this is positive or negative. Right? So if it is a positive thing, that means f of x is greater than fc. Right? That means what? X is ascending or descending? That means c is not a maximum point. Similarly, do the other side. If f dash of c is negative, c is not again c is not a maximum point, right? So in both the cases, you arrive at a contradiction, and hence f dash of c has to be 0. Verbally बोल दिया proof, लिख भी सकते हो ये सब, right? Got it? Proof समझ में आया? Actually क्या है, तुमको आइलर की तरह सोचना चाहिए. He used to do calculations because वो उसकी आंखें नहीं थी, right? तो mind में calculation करता था, right? So you can also do the similar thing. Think about it without, can you write down? So okay, लिखना पड़ेगा थोड़ा सा तुमको, नहीं तो अभी you are, at a very young age anyway. So suppose f dash of c is not equal to 0. अरे यार, f dash of c is not equal to 0, right? So first case, if f dash of c is positive, then we will have limit x tends to c, f of x minus f of c divided by x minus c is positive, right? And this is true for say if limit is there, obviously, in the neighborhood of c, this will happen, right? For some delta 1, हमने इसका नाम delta 1 कर दिया, right? That's okay. This will happen. No, that means where delta 1 is a suitable positive number, that means if we take x to be an element of c comma c plus delta 1, right hand side of c, right? Delta 1 is width of that interval, right? So in that case, x minus c is positive. For these values of x minus c is positive. And hence we will have that f of x minus f of c is positive. That means this is a contradiction because c was a maximum point, right? So this is a contradiction to the fact that c is a maximum point, right? Got it? Any question at this point? It's very clear. C is a point where the function attains maximum value, right? Okay. So now we are saying that, yeah. Why this is there are multiple ये हम गारंटी कर रहे हैं so okay so suggest on MATLAB draw a function, right? So there will be a lot of maximum, minimum value, and so on and so forth, and see that this is going to happen. Okay, right? It's a very intuitive thing, but at least you see the figure, then you will say, okay. So I think I will ask the TA to show you some of those things pictorially, right? Anyway, so similarly, if f dash of c is negative, we can do the similar thing, right? I leave it, right? If f dash of c is negative, we will have this limit is less than 0, right? And then from this interval, I will choose x, which is on other side of the interval, right? And you arrive at whole thing. Again, I told you, I think, see, when we have to arrive at a contradiction, I can take it is my, I have to choose some values for which I can arrive at a contradiction, right? Got it? You have all the time the same problem, right? If you have to arrive at a contradiction, means now I have to produce some values for which it is not valid. That is enough. I don't have to verify for everything. Okay. Now I can mention Rolle's theorem. If f is continuous, real valued function on a closed bounded interval a comma b, with the condition that f of a is equal to f of b is equal to 0. If it is differentiable, if f exists for all x in open interval. Right? Then there is some point C between a comma b where derivative of c will be 0. Okay. So this time function is continuous on a closed interval a comma b, closed and bounded interval a comma b, and real valued function, the values are real, right? If at the end points of the interval function, the value of function is 0. Okay. That's very important thing. And if the derivative exists for all interior points between a comma b, right? Then there is some point C between a comma b where the function, the derivative of the function is 0, means the tangent is parallel to x-axis. At that point C, right? Now we can prove this using the pre-Rolle's theorem. Okay, so it's very easy. Let's show you that. First of all, if f of x is 0 on a close b, I mean, then nothing to show, it's trivially true. So if f of x is positive for some x in a comma b, nothing to show. Then maximum value of f on AB will not be at the endpoints, right? Okay, so I'm saying that if f of x is positive for some x between a comma b, then the maximum value of f on closed interval will not be at the endpoint because there the value is 0. It cannot be maximum, right? Okay. And there is a result that if f is a real valued continuous function on a closed interval, then f attains a maximum or minimum value at points of a comma b, right? This result we are using anyway. So therefore f attains a maximum value at some c between a comma b. Okay. Now using pre-Rolle's theorem, what is pre-Rolle's theorem? Again, I'll just go back. If function is continuous on closed and bounded interval, if f has the maximum value is attained at some point c, then derivative is 0. Right. So here f attains a maximum value at some c, so the derivative will be 0 at that point. So if f of x is negative, similar thing, you can do similar arguments. Okay, so you can do the similar arguments. You are using again pre-Rolle's theorem. You can arrive at the proof. So I think अभी इतना काफी है, right? ज्यादा नहीं, शास्त्रार्थ है, विद्या का पारावार नहीं है, ऐसे मनुष्य सदैव मूल तत्वों पर विचार करना चाहिए, राइट? ये मूल तत्व आज के इतने ही थे. So next class, do we have another class this week? अरे यार. Last? अच्छा, पढ़ नहीं पा रहा. If f is negative, similar arguments hold. So you can do the similar things. Okay. Yeah. Right. So I hope this is okay. We are going to give you some more bonus problems. Problems जितनी रहेंगी उतना अच्छा रहेगा for you to do, right? अभी तक कितनी प्रॉब्लम हो गई? 40-50 तो हो गई होंगी. So you will enjoy more. हाँ. ये सोचो ना. It's not partial differentiation. It's a fractional differentiation. Fraction number of times I have to differentiate. Half times, 3/2 times differentiation. Something like that, right? So means square root के times I am differentiating a function. कौन पूछ रहा है? कुछ पूछ रहा है? Okay. So actually again and again I am saying that अभी भी समय कुछ नहीं हुआ है. अभी आज 9 लेक्चर हुए हैं, right? You have enough time. 18th exam is there or 18-19? 18 को रख दें हम लोग. पहला एग्जाम कैलकुलस का ही तो अच्छा रहेगा, राइट? तो बाकी तो सब आसान है ना. पहले खत्म हो जाएगा तो टेंशन फ्री. हर एक का पढ़ने का तरीका अलग है. So please, actually, you should study daily. Again, study in group. If you are having difficulties, discuss on the WhatsApp group. That is your first. I think some of you are using it. In the worst case scenario that you are not able to find a solution, you can see in my office. But obviously, I am not going to tell solutions for everything, right? So, because I have to encourage your own thinking, independent thinking, right? But I will give you hints, and that is enough, right? Tutorials also you can ask. You should ask as many questions as possible. This is very, very important. You should not miss the bus. I don't want any single person, whether sitting in the corner or from any background or whatever. You need to be good in mathematics, right? And you can enjoy it, right? Beauty, right? Okay. So thanks a lot. We will see you in next class.